Next part, the second part of your third unit, part 2, is schema refinement. Means refining of a schema. What do you mean by schema? Anyone? Check. No one. Okay. Schema. What do you mean by schema? It is a structure described in a formal language, which is supported by a Dbms. Means we can say that it is a organized within a relation database. Means how the data has been organized within a relation database is defined by a schema. We can simply say a schema is a structure, right? So schema refinement means why we need to do a refinement for the schema? Well, because of some certain reasons. So in schema refinement, we'll see some topics like here. The problem caused by the redundancy. Redundancy means what? Duplication. If we are maintaining a duplicate records in a table, while we are accessing those records, it's going to be create some problems, right? So those redundancy has to be removed. Those duplicacy has to be removed. So what are those problems caused by that? We are going to see in this topic. Decompositions. Decompositions means if we are maintaining a single table for storing a data, then it's also be a problem. That means again to retrieve data, we are going to face some issues, right? So we need to decompose those tables into further relations, means further tables, splitting. Problems related to decomposition, we are going to see functional dependencies. Functional dependencies means it is also a constant that specify the relationship between set of attributes where one set can accurately determine the value of other set. Means one column depending on another column. Like for example, if I say, okay, I'm maintaining a student record which is storing some student details as well as some course details. So student ID obviously depends on course ID, means which student is taking which course. So it is somehow depends on student is depends on course and course is somehow depends on student. So those functional dependencies we are going to see in this topic. Normalizations. Next topic we are going to see in that is normalizations. So what do you mean by normalizations? It is a process of minimizing the redundancy. It means removing the duplicacy from the tables. The next we are going to see some normal forms. So we are having some 5 types of normal forms, that is 1NF, 2NF, 3NF, BCNF, 4NF, and 5NF. So these all normal forms we are going to be discussed here, and lossless joint decompositions means this is also one set of decomposition, mean decomposition of a relation into further relations with the help of using joins. Means this decomposition assures that okay, if we are decomposing the table, the data is not going to be lost. The data is going to be the actual data what was present before decomposition. So this is the assurance we'll get from the lossless joint decomposition. Multi-value dependency means more than one column is going to be depends on more than one column. I have just now I have said here one column is going to depend on one column. Means student ID depends on course ID, but in the table some situation occurs here where multiple columns are going to depend on multiple columns. Now let us see what is a schema refinement. It refers to refine the schema by using some techniques. So the best technique to refine the schema is decomposition. Decomposition means what? We are decomposing or splitting a table into some other tables. Means splitting one table into 2 or more tables. Now, so not only with the help of decomposition we can refine the schema, but with the help of normalization also we can We find the schema. So what is the normalization? It is a technique of organizing the data into the database. Means if some any duplicacy is there, it will remove the duplicacy with some set of operations. We will see when we are discussing the normalization. Okay. It is a systematic approach of decomposing tables to eliminate the data redundancy and undesirable characteristics like insertion, update, deletion, and release. Means what the normalization is doing, it removing the data redundancy as well as undesirable characteristics like insertion, updation, deletion, anomalies. Anomalies means what? It is somewhat I can say is problems. Yes, it is dependent. It refers to the problems that occurs after poorly planned and normalized database. So anomalies are going to be referred as a problem that occurs on a particular time of insertion or deletion or updation. Those problems are termed as anomalies in Dbms. Okay, so those problems can be happen in a situation of poorly planned and normalized unnormalized databases where all the data is stored in a single table, or we can call it as flat file database. Means we are storing within a single file. Redundancy. What do you mean by the redundancy? It refers to a repetition of the same data. Means maintaining a duplicates record within a table. Now, next first topic of your part one, we'll see that is problem due to redundancy. What are problems we are going to be face? Anomalies means problems refers to the problems that occurred after poorly planned and unknown database where all the data is going to be stored in a single file, that is flat file. So what happens when we are maintaining all the data in a single, that is a particular only flat file? What happens? We'll see on your screen. You can see one table which is having the column as SID, SNAME, CID, CNAME, fee. Means student ID, student name, course ID, course name, fee. So all the data is stored in a single table and it is having some duplicacy, same rows repeated, right? AC1C, AC1C, AC2C, okay? Some duplicacy has been repeated here. So what anomalies are going to happen in this, we'll see. First is insertion anomalies. It may not be possible to store some more information unless some other information is stored as well. Means it is course also we need to, if we are going to store some student details here, we are supposed to know about the course also, which course is opting. So that is refers to insertion anomalies. Redundant storage. Some information is stored repeatedly. Means here you can see C1, C1, A1, right? So it's making duplicate storage. Update anomalies. If one copy of redundant data is updated, then its inconsistency is created unless all written copies of data are updated. Means if we are going to update, the CID also is going to be updated, right? So that leads to duplicacy. And deletion anomalies. It is not possible to delete some information without losing some other information as well. Means if I am deleting a record S3, here the new course which has been added also is going to be deleted, right? So this leads to deletion anomalies. Let us see this briefly. Insertion anomaly, what it does. If a tuple is going to be inserted in referencing relation and referencing attribute value is not present in reference attribute, will allow inserting in referencing relation. Means, for example, on your screen, we are maintaining two tables, that is one student table, student course table. In student table, I'm maintaining a 4 student record with student number 1, 2, 3, 4. And student course, I'm maintaining a record of the course, which student is taking which course. Okay. So for example, I'm trying to insert a record with the student course. In a student course, I'm trying to insert with the student number 7. So it's going to not allow. Why? Because in the student table, I'm not having a student record with the student number 7. So as they are in relation, this thing is going to be happen. So which leads to insertion anomaly. Deletion and updation anomaly. What is this? If a tuple is going to be deleted or updated from the reference, and reference attribute value is the referencing attribute in reference relation, it will not allow. Means if two tables are in a relation and we are trying to delete one record from a table, either a student or a student course, it's not going to be allowed to do so. Why? Because they're in relation, right? If we are trying to delete a record from student table with student one, it's not going to allow me. So if you want to delete or if you want to make the deletion operation to be occur, we are supposed to maintain two things. That is the query with two things, that is on delete update cascade. When we are writing a code, we are supposed to mention this. If it so on delete update set to null, on delete or update set to null. What happens when we are using this command? When we are giving this insertion command as student number one to be deleted from this. So it's going to be delete and it's going to set. If a tuple is deleted or updated from the reference relation, and reference attribute value is used by referencing attribute in the referencing relation. Whatever the value which is going to be referenced, those values going to be taken, and the which is it will delete the tuple from the reference relation and set those values to null values. Means if I am set is deleting this one, okay, it is going to delete from this, and here it's going to mention it as null and null. Referencing table, it's going to be maintain it as a null. On delete update cascade means tuple is deleted or updated from reference relation, and referenced attribute value is used by referencing attribute in the referencing. It will delete the tuple from reference and reference relation as well. So if I am giving this command, then this the record with respective one is going to delete here, as well as from student course also. This record is totally deleted. This record is also totally deleted. So this is all about your anomalies.